Photogrammetry drone team, and we will be discussing damage analysis through drone photos. In collaboration with the CSE team, the goal of our project is to render 3D virtual landscape models of insured property for State Farm from images captured by a drone. The photogrammetric process will aid in the damage assessment of insured assets in post-disaster sites by providing a safer and faster alternative to streamline insurance claim services. The current insurance claim process requires agents to visit post-disaster sites to assess damages, which can be dangerous and lead to long delays. Thus, a photogrammetry drone ensures greater safety and efficiency by capturing and uploading high-quality pictures that can then be used to create a 3D virtual landscape for an interactive damage analysis experience. Our requirements are to build an autonomous drone capable of avoiding obstacles and covering 2,500 square feet, as well as the elevation of a 3-story building. It must capture and store pictures into a cloud and complete each survey scan within 3 battery recharge cycles. The drone must also abide to the rules imposed by the Federal Aviation Administration, such as it cannot weigh more than 55 pounds nor fly above 400 feet. With these in mind, we designed a quadcopter capable of long-range RF communication. Its photogrammetry system will allow picture capturing and storage so that they may upload into a cloud once a Wi-Fi connection is established. It will also have an integrated obstacle avoidance system to safeguard its autonomous operation. One of the requirements of our project is autonomous flight. The stable flight can only be achieved once the PID, proportional integral, and derivative values for the directional control are tuned. The PID values can differ according to the structure and the weight distribution of the drone, which is why tuning these values to fit our custom UAV is essential. The tuning process starts with a full manual control, followed by gradual increase of autonomy. The PID values are gradually adjusted based on the direction of oscillation observed. Once it is manually flyable without crashing, the drone can self-correct the PID values using the auto-tune feature. This tuning process is critical prior to implementing the structure scan feature of our drone's HearLink system, which makes use of stable autonomous flight to follow a grid-based flight navigation to capture images with respect to structures of interest. The process in which these pictures are captured involve the use of a high-quality GoPro Hero 7 camera, which receives commands from an onboard Raspberry Pi that connects to the GoPro's Wi-Fi and runs an application programming interface that allows it to dictate the capture speed intervals to permit a 60 to 70% image overlapping necessary for the photogrammetry processing. While in flight, the captured images are locally stored within a solid-state drive until the drone is able to land and the Raspberry Pi establishes a Wi-Fi connection, permitting the cloud upload to begin after receiving the pilot's command. Numerous flight tests have been conducted that resulted in a flight time of around 10 minutes. To determine the success of each test, various flight characteristic information was gathered from post-flight logs. These included how well the drone follows the pilot's input, the state and accuracy of the GPS, and how much vibration the flight controller was experiencing. As seen in Figure 3, the actual values and desired values track each other, but there are a lot of oscillations as the drone follows the pilot's commands. To reduce the oscillations, we are performing PID and auto-tune testing on our drone to ensure the proper values are used to convey the drone's input tracking method. In conclusion, the part selection for our drone has allowed us to fulfill our project's requirements through the development of a robust drone capable of performing the photogrammetry scanning, cloud uploading, and collision avoidance when deployed to post-disaster sites. And now we will show a brief demonstration of our drone in flight. And with this, we conclude our presentation and would like to give a special thanks to our State Farm sponsors, Amy Simone and Dawson Richens.